turn over. All right, so here we go. It's a review for the cumulative. We already did a review for the cumulative yesterday, but we're going to do a little more review for the cumulative. Some kids were absent for seeing a good speaker yesterday, and so we're giving an extra day of review for this cumulative. So why does this matter so much? Here might be a kid's grades so far, and then this third grade is up in the air. It's the one we're taking tomorrow, the cumulative. Do you get, if this kid gets another C on this cumulative tomorrow, then that C is going to stay the same because it's not going to be an improved grade. And then they're going to average a B minus. Whereas if this kid improves and actually gets an A on the cumulative tomorrow, if you get an A on both parts, then obviously you would have had an A on this part. And that means that this gets to go up to an A. And what's their average? A straight A. Okay, so for some of you, this is a difference right now between this test. Could make the difference between you have a straight A average over 3 tests, which is really strong. That means you could get a B and still have an A. Okay, as opposed to if you just kind of slack off and get a C on the test tomorrow, now you got a B minus, and it's stuck that way, all from one test. So the cumulative is a big deal. All right, so what's on the cumulative? Well, everything that was on the last 2 tests. Now we're getting far enough away from the most recent test, the test we just took, that it probably wouldn't hurt to review a little bit of that because now it's been a couple days, all right? But I think this is the kind that will stump people the most of the things we've practiced. Let's see if I'm right. F of x, everybody write this down, equals x squared plus 3x minus 1, and g of x equals 1 over x. What is f of g of 1? What is f of x plus 4? These are completely separate questions. I'm going to pause for a second while you try those two. This is functions that are eating other functions. It's called composition of functions officially. In case you're stuck on how to get even started, you'd start with g of 1. So then you go over here, and 1 is the x value. They told me x. If you put it here, you're just naming it. G of 1 is 1 over 1, which is 1. So that part is 1. And then you just got to do f of 1 now. That's what's left. So then you put it here, and then you end up with 1 squared is 1 plus 3 minus 1, and that's equal to 3. Raise your hand if you had 3. Okay, awesome. F of x plus 4 means you're going to go stick x plus 4 into this function. Into what function? There's 2 of them. Well, it says f, so you can know you're sticking it in the f function. So here's my f function, and I'm going to drop in an x plus 4. And now here's a really critical oops. X squared plus 16. Nope. This is x plus 4 and another x plus 4. That's what squared means. Plus 3x minus 12, nope, plus 12, sorry, minus 1. That was me distributing out that. Now I'm going to distribute out this. Take a second, finish it all off, get your answer, check with the kid next to you. All right, here's the final. X squared plus 4x plus another 4x makes 8x plus 16. Now I'm just copying this. Now I'm going to put it all together. X squared, there's no other x squared, so it's just x squared. 8x goes with the 3x, makes 11x, and the 16 and the 12 makes 28. Take away 1, 27. There's what I think the final answer is. Anybody agree? All right. Any questions? All right. So then, what was on our most recent test? Like, what was that even on? Anybody name a topic? Transformations. So if I gave you something like this, you would really have a chance to screw up, especially on the inside. Like what order you should do this in. You should use like, oh, by the way, if you're gonna do this, would you please start on the inside? Even though I know legally you could start on the outside, please start on the inside. And it would really be easy to mess up the inside because it's the opposite of what you would think, and it's in the opposite order of what you would think. And then there's two things on the outside that are the vertical things. Use words like vertical, horizontal, shrink, stretch, left, right, reflect. And remember, if you say reflect, you got to either say over what axis or you got to say vertical or horizontal reflect. I think it's easier to say vertical or horizontal. All right, that's got to be in the right order. And if you all start with the inside, there's only one. Well, okay. No, in this case, there's only one right order. It has to be 1, 2, 3, 4 in the exact right order. Talk to the kid next to you when you're done. Okay, let's see if you did them in the right order. First off, you go on the inside and you look and you see, is there any parentheses that are inside the parentheses? And there aren't. That's the worst kind because people get those confused so much. But there's none of that. So then you look for, is there multiply in here? Yes, there is. Is there add? And which one normally comes first? Multiply. So you don't do that first because it's the opposite of normal order. So that 4 goes first, which means left 4. And again, if you think it's right 4, I get it, but it's counterintuitive. Left 4. Then there's this part, which is a, ooh, careful, seems like a shrink, so it's actually a stretch. What kind of stretch? It's a vertical or horizontal? Horizontal stretch. BFO by a factor of 2. And if you use stretch, you should use a whole number. And again, it follows the theme of opposite of what you would think. You don't say a half. All right, and last but not least, the outside stuff, which is this first because it's technically a multiply by -1. And multiplies come before adds in the normal world, and this is the outside where things are normal order. So, vertical, reflect. There's always a few kids that want to say the axis. I'll tell you. It's over the, and if it's vertical, you got to go like this. That's X, that's Y. Vertical's like this. It's going over the X-axis. All right, and last but not least is that, which is up 8. Did anybody hit all 4? Perfect. All right, that's less than half of you. I understand. Do you have any questions about why it was that way? All right, so imagine for a moment that it was that same kind of a problem, but you had to graph it. Do you remember me saying you could pick any points you want, but you should be smart about what you pick? Do you get if I put in 1, I'm going to get a pretty big number? Because then I'm going to get 5 squared is 25, and then it's -25 plus 8. It's going to go off the graph. So then if you can pick any number you want, but you should be smart about it, what do you say? -4. Good call. Because then that makes the first part 0, which means it's going to stay under control on size. -4 is a good call. And so you also should put in -3 and -5. I want everybody to find those 3 key points. And in a moment, I'll have you compare. Okay, compare with the kid next to you, please.
She said -3 plus 4 will be 1, then the square will be -1. Oh, I forgot.
All right. If I put in -3 or -4, I'm going to start with -3. Then I end up with 1. Squared is 1. Then I make it negative. -1 plus 8 is 7. Raise your hand if you had -3, 7. Awesome. All right. Dice of Destiny. Who is answering next? It's row 4. Last person. Macy, that's you. All right. Raise your hand if you had -4, 8. Okay, awesome. And the last one, row 1, person 2. Lou, that's you.
-5, 7.
7. Who can say that 7 is also right? You guys agree? Okay, good. Then, if I graph this thing, I feel like it's going to look like something. Think for a second. Is it a V or a U shape? I heard a V, I heard a U. So, is it a V or a U shape? It's a U shape. There's a difference. Let's make sure you understand the difference. A V shape, that's an absolute value. Is this an absolute value? Then this is not a V shape. This is a parabola, which is more of a U shape. If you look at the points on it, they'll curve. All right. So, there, it's a U shape, but it's been flipped and moved and moved. So if I move it to that spot, it'll be flipped over, which will be like this, and then it'll move 4 to the left and up 8. So basically, when it's done, it should look kind of like that. Do you get how that one's flipped and moved left and up? Does that make sense to you? And then if you actually graph these points, look at that. -3, 7. -4, 8. -5, 7. And they'd be right on your graph, and it's all making sense. All right. There's one kind of graph that's the nastiest, and it'll be on your test again. I would bet you money, and it's y = 1 over x. Why is that important? Because it's got asymptotes. Would you agree this one has been moved left 5 and down 1? Would you please make a quick sketch? The old original 1 over x graph looks like this, but the asymptotes have been moved. I like to think of it as those asymptotes have been moved kind of like this. This is not right. But it's like those asymptotes get moved somewhere, and then you draw the graph again. I did not move it to the right place. Would you please make a quick sketch of it moved to the right place? This is the nastiest one. I had to mark this one wrong more than all the others on your actual test. I get it. It's tricky. But if you move the asymptotes, see the kids that had it wrong, they had one thing in common. They didn't have the asymptotes put in. They were just trying to do it off of points. And then if you mess up one point, all of a sudden you got a point here and a point here and another point here, and you're like, I don't even know what's going on. But if you know what the shape is, and you know the asymptotes have been moved, and you draw them in, then it's really not that hard. So on this kind of graph, I wouldn't start with my X and Y chart. I would start with a little sketch and then go, okay, I think it looks like it's supposed to be here. And then I would find my X, Y points. All right, did you already put in your dotted line, moved left 5 and down 1? And do you get that the graph should sort of look like that? Does that make sense to you? Then should I put in like X is 2? No, look at it's over here. That's dumb. There's no points over there that are important. All the points you care about are negative. So maybe what would a smart point be to start with? X is what? -5. And a lot of people are like, put that 0 on the bottom. That's good. -5 is the asymptote. If you make 0 on the bottom, you just found the asymptote. Now find me 2 more key points, like that one and that one. You should be able to use logic to figure out where they are. We started with -5, and that wasn't down. That was a good start. It just wasn't a point. It was an asymptote. I'm going to pause for a second while you finish this one. Okay, Dice of Destiny. I'm going to call on... Oh, Macy, it's you again. Sorry, it's just fate. So, What'd you get for a point that wasn't negative 5 comma something? Negative 4 comma 0. I'm going to double check that. I'm going to put the negative 4 right here. And then I get 1 over 1, which is 1. 1 minus 1, 0. You're right. Good job. Negative 4 comma 0. So my sketch is off. It should actually be right here. I wasn't tragically off, but I was off. It should be touching right there. All right. Okay, how about this other point over here? Well, if this was negative 4 and the asymptote was at negative 5, I wonder what I should put in. Maybe negative 6. And they're all close to each other, which makes sense. And then I put in negative 6 here. And negative 6 plus 5 is negative 1. 1 over negative 1 is negative 1. Negative 1 minus 1, negative 2. Who had negative 2? You were correct. And that was this point right there. Negative 6, negative 2. And then my green line can go through that and get closer and closer to the asymptotes. And there we go. Is it perfect? No, but I would have given credit for this on the test. It would have been good enough. I got the asymptotes in there, and I got all we require on these is 2 points in the asymptote. We're really hoping you're going to put on that point and that point, because those are the 2 that work out nice. And the asymptote. All right, cool. Do you get that you have a bunch of work time because you already have all the questions in a packet? If you were nice to yourself, you already did a whole bunch of that packet, and the rest of it is due tomorrow. Yeah, you're shaking your head. What does that mean?
We were nice to ourselves.
Oh, okay. Then you have a bunch of work to do, but you have a bunch of time right now. Okay, this counts in the grade book, so do it and turn it in the Dropbox. Yes, right now. So that's the end, and all right, I'm done with lesson for today. You guys have the rest of the hour to work on that, and I can hand back old tests and that kind of stuff.